be again about some facts that are by now fairly familiar. Since the 1970s, we've seen a large decline in marriage rates per unmarried woman, rise in unmarried sexual activity of unmarried women, just to be more precise, rise in unmarried birth rates, and rise in abortion rates. I'm not going to document that very carefully. There's more information in the paper. I'm worried about running out of time, so I've cut 40 slides out of the talk. So one way to summarize this is to think about the unmarried share of births, which rose from about 10% in 1970 to 35% by 1990 and continued to rise thereafter. The rise in unmarried share of births is not just about cohabitation. So even in 2008, which is long after my analysis stops, only 28% of unmarried births were to cohabiting couples, and only 35% of births to never married people were intended at conception. So much, what we're seeing here is a rise in sort of accidental pregnancies and such, which is a bit paradoxical given the timing of this change, because the timing overlaps with the liberalization and effectively improvement of contraceptives and abortion. 1972 was the date of a famous court decision ensuring that single women everywhere in the US had access to whatever contraception method they wanted to use. And we see that going from the condom to the pill is actually a very significant change in pregnancy rates. So women who use condom or diaphragm as their primary contraception tended to get pregnant typically at a rate of 15 to 20% per year, compared to about 5% per year for women using the pill. It's even more striking if you look at the UK, because they have data on unmarried births going back much further. And what you can see, in 1974, the UK granted free access, i.e. no charge, to the pill or contraceptives to all women in the UK. And you can see what happens to unmarried share of births around that time. This goes from 1846 out to, well, I guess about 2000. And you can see really that starting in the mid-1970s, the unmarried share of births just shoots right up. So what's causing these kind of changes? The timing of the events suggests two potential kind of stories. One is the technical change story that I'm going to focus on. So more effective birth control or liberalized abortion. And probably the most famous paper in this area is Akerlof, Yellen, and Katz, which I'll refer to as AYK hereafter. And then other papers people in the room have worked on. So I've more recently, Greenwood, Gunnar, and Villaverde have a paper on investment in the moral standards of the children. The alternative kind of explanation might be to look at changes that, such as we've just seen, related to the labor market and improved labor market prospects for women, perhaps improving the value of single life. And there are some papers that people here have worked on as well in that vein, and I'm going to ignore them from here on in. Okay, so this is a paper about technical change. And I guess that, if you want to try to understand an event, a phenomenon like the rise in unmarried births, it's useful to decompose it empirically. So this is going to be, I'm going to show you a purely empirical slide where I'm going to decompose this into the fraction of women who are sexually active, the contraception method they're using, the abortion rate per pregnancy, and the marriage rate per pregnancy. And then we can compare the 1970s and the 1990s and ask, what if any one of these margins had stayed constant? What would have been the impact on the unmarried share of births? And what we find out is that the main driver of the rising unmarried share of births is A, the rising sexual activity rate, and then 2, the declining rate of marriage per pregnancy. Okay, so that's what this table does. So it's not as dramatic as I hoped it would be. But what you see here are the different types of margins that are important. So this is a fraction of women not sterile. This is sexually active using contraception method 1, which you're meant to think of condoms and diaphragms, etc. Using contraception method 2, the pregnancy rates under each contraception method, whether women who are not using condoms, their contraception, their pregnancy rates, finally the abortion rate per pregnancy. So these are, the reason I'm stressing this list is because I'm actually going to write down a model where all of these margins play a role so we can think about calibrating to these numbers. And the message of the table is that if we hold each of these guys constant, what you see here is the, what we would get as the birth rate per unmarried woman. So the birth rate in 1970 was about 0.026. In 1990, 0.048. Holding the rate of sexual activity constant, so instead of letting it go up to 0.75, the birth rate per unmarried woman would have decreased to 0.015. And we get a similar result if we hold constant the marriage rate per pregnancy, which is about 0.6 according to Akerlof, Yellen, and Katz for the 70s, and falls to about 0.2 in the 1990s. So having sex in the last month.
And what do you mean by marriage per pregnancy?
Shotgun weddings. So marriages in which the conception appears to have been to date before the marriage. So births within the first 9 months of the marriage. Actually here it's, when I can't count it, it's actually 8 months.
Where do you get the sexually active data?
So this is, so in principle this comes from the National Survey of Family Growth. Now they ask questions about sexual activity. Also, Stephanie Ventura has a paper from the Vital Statistics Bureau, has a paper where she describes some of these statistics like the not sterile. So not sterile for 90 comes from her paper. Not sterile for 70 is just I just copied it over. But, I mean, I have no information about not sterile.
What is the age range?
So this is 18 to 44. Okay, so
actually that's problematic. I thought an increase in sexual activity reduces increases sterility. Isn't that an issue as well?
I hadn't thought about that.
Hopping it over is a big.
How big do you think?
I don't know, but,
yeah. It might be problematic theoretically. I mean, I did look at Trissell and these guys, and they seem to be silent on the issue. But if you have something,
there's something about one of the reason for the fall in teen births, pregnancies was something about fertility. I mean, how fertile, that fall in fertility. I don't know.
Okay, so I don't know either. I'm going to stick to the stuff I know.
Are there any other numbers you made up?
Other numbers I made up. Good. I refuse to answer on the grounds that may incriminate me.
What are the numbers in the concept?
I'm sorry?
The numbers in the concept?
Yeah, so these numbers are, I'm just showing you what I'm holding constant in each case. Okay, so this number here, sorry, I'm not sure where this 0.09 comes from. But these other numbers, you can see 0.25 comes from here, 0.25 from there.
Why the other everything's on 1990 basis?
Because I'm using the, I'm going to refer back to the National Survey of Family Growth, which goes from 1990 to 95. Okay, so the main paper on this is the Akerlof, Yellen, Katz paper, the first paper to really focus on these margins. And the main idea there is that there was a social norm. The social norm of shotgun weddings, which meant that men had to marry their pregnant girlfriends or bad things would happen to them. So the deal was, there was this implicit deal that they could have, unmarried people could have sex provided that the man was willing to marry the girlfriend should she get pregnant. And then their idea is that with improved birth control, these pregnancies became strategic rather than accidental, and therefore the social norm was eroded. Okay? What we do in this paper is argue that actually shotgun weddings is a symptom, not a cause of the change in society. Marriage rates declined generally, pregnancy rates went up, and so naturally the shotgun wedding ratio per pregnancy tended to go down because marriage was just basically fell out of favor for some reason or the other that we'll explore as we progress. And one piece of evidence for this that's nice is that the shotgun marriage ratio, as shown here, actually didn't decline at all. Okay, so shotgun wedding per pregnancy declined, but not shotgun wedding per marriage. If you break it out by category of women, so these are women without kids under age 25, you can see the rates about 16% for these women in 69-70 and about 16% in 1995. And you go through the different categories and the result comes out strikingly similar. Right? So not really much change in shotgun weddings for marriage. So the hypothesis that we're going to explore in this paper about the decline in marriage is that essentially that there's a high elasticity of sexual activity with respect to the risk of having an accidental pregnancy or birth. Pardon me? There is risk, yeah, but there's no analysis of risk in the sense that Glenn would like, where we have a more flexible attitude to how we model the preferences. That fair? Yeah? Okay. So the main elements of the explanation of this are going to be, in the model, timing of children is going to be very important, and this helps us understand why, although people like kids in general, I think that there's high rates of contraception and of abortion. There's going to be idiosyncratic abortion costs, so only half of unwanted pregnancies are aborted, and it's hard to explain that unless there's some kind of idiosyncratic variation. We chose to put it on the abortion costs. And there's going to be a fall over time in the marriage market penalty for single mothers. So non-mothers used to marry at a much higher rate than single mothers, and now they marry at roughly the same rate. It means what I just said, actually. So it means that in the past, having already had a baby was a huge disadvantage for your prospects in the marriage market.
Are there going to be anything about changes in welfare policy?
No, this is going to be really a representative kind of agent kind of model in many ways. And so effects of welfare aren't really going to play a big role. Okay, so what we think in relative, I think it would be fairly easy to write down a schematically one-period model or two or three-period model of what was going on here, and people have done that in the past, perhaps not as easy as I thought. But
sorry, I think Knowles was asking about the welfare policies.
yeah, I understand. So the welfare policies are about giving a little bit of money to poor people. And that's not really what this change over time is.
Supporting women with children, the timing of that.
Yeah, but single moms are not just poor moms. I mean, if you look at the way things have changed. Yeah.
But presumably that raised the value for single women of
Yeah.
having a child relative to not having.
Right. So I have an alternative paper where I went down that route,
That's what I was wondering.
and I just didn't find that
Doesn't do much?
if you're doing it, if you're looking at just the averages over people, that stuff is really small. Where it really matters is if you're focusing on
Very low income.
right, exactly.
You do take into account there are a bunch of single mothers out there who used to be married.
So in this version of the paper, I'm not going to do that. So in other words, to get that, you need divorce.
Yes.
And so people complain that I had too much, like Marco, for instance, complained I had too much stuff going on in this paper. You know, so I said, okay, I'm going to just take out some of the stuff, focus on the unmarried birth rates, and defer discussion of, say, the welfare of kids.
But you would measure unmarried birth rates kind of correct.
That's right. So I'm talking about unmarried birth rates,
Yes.
not about.
Not kids living with unmarried mothers.
That's right. Yeah.
Can I answer the question that you asked before?
Uh-oh. I was just.
Why do you need
Two.
two markets rather than one? Rather than you go to the same one and you get an outstanding marriage quality and you get married. What are the gains that you cannot do with only one?
Yeah, so the idea was that, I mean, what's going to happen is that in the marriage market, there's no sex before marriage. And so what we wanted to do was really get at why it is we see this increase in births before marriage. And so the idea is that people are switching from one market to another. They're switching from one mode of getting married to a different mode of getting married. There's courtship and then sex. That's one mode. And then there's sex and then potentially marriage. That's a different mode.
As opposed to trying out to see because of girlfriends.
Well, you can do this, yes. You can do this, yeah. Trying out, yeah.
No, but to try out this one market, that's the best.
Right. But not everybody goes that route. So if you look back in the 70s, you know,
You're saying the option of the casual sex in the model can lead to marriage with a partner there?
I'm going to allow for that, yes.
Okay.
Okay, so the other critical element here is going to be that costly birth control choices. So you have the choice between two different methods of contraception and no contraception and abortion. And the idea is to write them all in a way that we can calibrate it to annual statistics for the 1970s. So we're going to be looking in sort of the tradition of the search and matching guys, looking at transition rates, like rates of pregnancy, marriage, births, abortion rates, and then contraception usage. And we're going to compare the model with and without shotgun marriages. That statement's not very clear yet. Hopefully it'll make sense later in the paper. And then the idea is to use the model to generate some patterns of the 1990s by changing the availability or the cost of abortion and essentially the pill. So the main results in terms of what we get is we start with limiting the model to only one child, a maximum of one child. So that means that women, that mothers, we're abstracting from the matching and sexual activity of mothers, unmarried mothers. And we find that it's really easy to generate this sexual revolution in the sense that we get, by improving birth control, we get both a rise in the unmarried share of births and a decline in marriage rates. Now that's a paradoxical result, because we've improved contraception and yet you get a higher rate of accidental births. But what's interesting is that when you allow for shotgun weddings, then it becomes much, much more difficult to get this. And the reason is, of course, that shotgun weddings are still attractive. Once you're pregnant, if you have no choice but to bear the child, then it's much better to be a married mom than a single mom. Abortion changes that calculus. But then the problem now is that it's very hard to get an increase in the unmarried share of births. Okay, so you add shotgun weddings to the model. Then you have the choice between either matching the the marriage decline or the increase in unmarried share of births. So it's a bit of a difficulty there. But actually increasing the possible number of kids that women can have seems to resolve that. So now higher set with k equals 2, so women, unmarried mothers can still match and have more kids. Then we get the rise in unmarried share of births for non-mothers. So one of the messages of the paper is that it's important to focus in this kind of analysis on what unmarried mothers are doing. Now, we haven't pushed it all the way. We've stopped at k equals 2. But in principle, even in the 1970s, unmarried mothers played an important role in understanding the unmarried birth rate.
Let me see if I understand. When you increase it to 2, you just sort of get more. Are you switching something from an extensive margin to getting it out of the intensive margin?
What happens is,
or are you fitting both still, or are you just sort of average these two together to get the average right without getting?
no, so I'm looking at the, right, so that'll become clear when I present the calibration. But essentially I'm looking, trying to match the birth rate for non-mothers, unmarried non-mothers. Is that what you're asking?
Well, I was wondering, you said what is it about this that sort of solves the problem?
Because now women have the option, I don't have to abort this one, maybe to avoid having too many kids, and maybe I'll just abort later one if I get pregnant in the future. In other words, you still have options in the future in terms of matching and sexual activity. You don't get shut out of the market.
So you still can sort of match the number of mothers that don't have, the number of mothers in some sense that are unmarried and have a kid, as well as the number of kids that are
more or less, yeah. So let me show you. I mean, it's going to be 30 minutes from now, or 29 minutes before I get to that table.
John, that's all comes from remarriage rates, isn't it? From marriage rates of mothers.
I'm not sure I want. It sounds like a trap, Victor.
No.
So tell me.
I would say that what matters in here is that by having a baby, a woman does not lose a lot of body.
Right.
And K = 1 imposes that through the back door.
That's exactly right.
And you can discipline that by the marriage rates of mothers.
That's right. That's right. And we're going to miss in some ways, but then you can apply the same logic and say, why don't we set k = 3? Okay, so I've dropped most of the empirical. The paper starts off with a fairly hefty empirical analysis to convince you that these phenomena that we're talking about are not driven by changes in, say, in education composition or age composition of single women. Okay, I'm going to assume that we all believe that, and I'm going to move on to showing you an example of a very simple model that generates some of the action that I've been talking about. So think of a world with an infinitely lived population of adults. There's a continuum of each sex, and N, M, and F are the masses of each. Men choose between, so this is NF, and these are the masses of single people, I think. So men choose between marriage and sex markets, and within each market are randomly allocated to the women. In the sex market, a matched couple has sex, and this creates a surplus, SX. And in the marriage market, a matched couple can marry and then presumably go on to have sex, but this is a one-period model, so we just draw the curtains and just leave it at that. Okay, so we
So what do you mean this one, that they're allowed to marry only those?
oh, that's just okay, right. So why don't I let them all marry if they meet? Just because in the end I want to give you a numerical example, and it's helpful to this helps me match the numbers.
You just have that it's harder to meet in the marriage market.
Yeah.
Is that
Yeah.
the same thing? Or you're saying they're matched? That they can marry?
It's possible, yeah.
And they meet, but they don't form marriage.
And so the important thing in the example, the important variable to keep track of is this phi n, which is the ratio of men to women in market n, where n can be either sex or the marriage market. So the surplus allocation in the matched, so there's this fully transferable utility here, if I didn't say that already. The surplus allocation is going to be as if the women were auctioning the match. So she gets the surplus if she's ended up with more than one suitor. And if she only has one suitor, then it's the male who gets the surplus, whether it's a sex match or a marriage match. So this means that the man is awarded the surplus with probability PM. Okay, and for women, the probability is QM. These omegas here.
I don't understand.
Oh, okay.
It's a frictionless market, right?
No, it's the market has friction. So what happens, the friction is, it's like an earn ball matching market. So there's all these women in the market, and then each man gets randomly allocated to one of the women in the market. So a woman can end up with one suitor, 0 suitors, or 17.
And of course, she can continue search.
That's right.
So you're taking
But in
into
this,
account
there's only one
the
there's only one period here, so there's only one match.
Ah, okay.
They'll later extend it to the case where they can keep on searching.
For the time being, short-term weddings don't play any role.
That's right. That's right. I'm gonna. Okay. So the idea is to clarify what's the mechanism before we add the bells and whistles.
As you I think asked before, is search crucial in this? Is this friction crucial here?
So what you
Or
need.
You just have a frictionless marriage.
What you need is a technology that lets you match different numbers of people together. So that means that some people are not going to get married because there's different numbers of people. Now, whether you call that a friction or you have, I mean, I think,
You could have a side and a short side.
right, yeah. So I haven't written it that way, but I think you could, and I'm not sure if how the mechanism would
The
work.
reason I started thinking about this question, the one you said, basically, if she doesn't have another suitor, she gets none of the surplus. While in the marriage market, in the Beckett type marriage market, she also has an outside option, which is the marginally worse man.
Yes, that's if she's not. That's if she's on the short side.
Yes.
Yeah. Yeah. Okay. So it's something to think about. Okay. So just let me tell you what I like about the model is I can tell you about the equilibrium in one slide. So if each market is active, then there's an indifference condition that must hold for the men. So their expected surplus in the marriage market equals their expected surplus in the sex market. I'm assuming men are in excess supply, so they're indifferent between participating or not in either active market. And gamma here is the male cost of participating. Okay, so this pins down the expected gains for the men. There's an indifference condition for women. Now for women, I'm not sure if I said this already, but women pay a cost that's stochastic for entering the marriage market, entering the sex market. So this means that the marginal woman will satisfy this condition. And so that means that the marginal woman, combining all three expressions now, we can write the identity of the marginal woman, i.e. her cost of entering the sex market, using this equation. Okay? So this equation exploits the property, this property here, that in the standard assumption for these kind of models is that the probability of getting 0 suitors is given by e to the minus phi n. Okay? So that's very convenient because it allows us to solve for the equilibrium of the model. And then what I have to add to this to make it relevant to the discussion we've been having so far is some concept of birth control. So if people have sex in the unmarried, if unmarried people have sex, they're going to have some probability of having a child. That's pi f here. And the consequence of that is delta v. So this is the change in, this is a utility penalty or a gain from having a child while unmarried. So the expected surplus in the sex market then can now be written as the utility from sex plus the probability of birth times the utility penalty of having a child. Now, for this example, we're going to set delta v less than 0 and interpret the pregnancy probability as the failure rate of the birth control technology. So that means we're just assuming that women don't want kids in this model and that they're all contraceptive. So that lets us write the, we can now write the birth rate to unmarried women in the static model. Easy expression to write out, if not to read. And then notice that it's all a function of the equilibrium parameters here. We can parameterize this model then. I don't have time to really go into the details of the parameterization, but notice that there's a big utility penalty for having a kid. There is utility from sex, also large, say, relative to the marriage surplus. And that's critical for what we're doing here. That's what generates the elasticity of sex participation. So I went the wrong way.
This utility is having kids or having kids in an unmarried?
Unmarried, yeah, unmarried kids.
So where are we seeing the static model?
What do we see in it?
Yeah.
Why do we do it?
Yeah.
Yeah. Okay, so here's what happens. This is the birth control failure rate plotted along the horizontal axis here. And this is the unmarried share of births. Okay, these two lines here. And what you see is as the contraception technology gets worse, if you move to the right, the unmarried share of births actually can fall. There's a region, you see here, where the unmarried share of births is falling. So with a good pill-like technology, you get an unmarried share of births around 0.45, like in the 1990s. And if you go back to technology like condoms or something, where the failure rate's around 0.15, you go to a low unmarried share of births. So what's nice is you can see all that working from just working out the equilibrium on one slide. Why would we get this perverse effect? Well, as you probably imagine, as the contraception technology gets worse, the participation rate in the sex market, this blue line here, is going down.
Well, this has to do something with the cost of the stigma or whatever.
Yeah, this delta V. This delta V. This has to be large. It has to be a really bad thing to be an unmarried mother.
I guess you don't need any restriction on the F distribution of this stochastic.
Okay, so good point. So the reason I have two lines on this diagram is to show you that as you increase the variance of that distribution, the effect is still there, but it gets moderated. Okay? So definitely, if you had a very, very large variance, this effect could be quite small. Okay, so the point, that's really the point of the slide. You can also see that this is the total fertility rate. And over the range where we see this perverse effect, actually the total fertility rate, i.e. adding up the married and the unmarried, is roughly constant. Okay.
Can you remind me again, what's varying across individuals that's making them choose different things?
The cost of entry. So the men are indifferent. Okay, over the two markets, so they're just mixing. And the women vary in their cost of entry into the sex market. They have a stochastic participation cost.
There's a big question. If that density is pretty tight, then small moves in sort of the value of something can create these. Everyone move from one market to the other, basically.
That's right. That's the idea. So that's why I showed the two lines on the previous slide. Yeah. Okay, so now I've got the basic idea here. The model obviously abstracts from most of the things I used to motivate this talk in the first place. So now I wanted to start adding those things back in. So what I care about, what I want you to notice particularly is the determination of surplus in the marriage and sex markets. So we didn't even talk about how surplus in the marriage market was determined. Determination of the fertility incentive, delta V. I just picked that as a large negative number to make my life easy. And we haven't talked about abortion, or we haven't modeled abortion and shotgun marriage options. So I'm going to say a few words about this dynamic model that, but really I had to cut out most of the slides, so if you have questions, please feel free to read the paper. So again, it's a discrete time, infinitely lived adults, a continuum of each sex, and these are the masses again. Okay, so now we have an infinite succession of discrete time periods. Women can produce up to k children. K is an arbitrary integer, so there's no limit here on how many kids women could have in principle. And people in the model are going to be either single or married. Men in the model are all identical, and women vary according to the number of children they already have. So when you have a kid, that becomes a state variable. Okay, and kids live with the mother. Utility perfectly transferable again. There's going to be for each type of household. This is single male. This is single female with k kids. This is a married couple with k kids of the mother and km kids of the husband. So km less than k, obviously, less than or equal to. So there's going to be a utility flow for each household type. And then the preference of over-timing the births is going to be represented by a utility shock, i.e. utility shock each period. So the idea is that people might really like kids, but unless this kappa shock is high enough, they're still going to contracept because the timing of children is awkward. Okay, so then again, matched couples in keep going here. So at the start of each period, there are two matching markets that open, the marriage market and the sex market. In the marriage market, sex only happens after marriage, and in the sex market, matching always results in sex, and potentially also in marriage. Then once the market's open, women learn their, well, actually let me move on, I have a picture for this somewhere. There we go. Well, here's a picture. So what happens at the beginning of the period, women find out their cost of entering the sex market. So if they have a high cost, they enter the marriage market. If they get matched, then they may end up getting married, and if they don't, then they try again next period. If they enter the sex market, then that's because they have a low cost, participation cost. Then if they get matched, they have sex and then potentially get married. Okay, I think I can skip over these details. So it's important to emphasize this. The way the market setup works, there's a separate submarket for each number of children that a woman has. So there's two big markets, market for sexual matches or short-term matches, and the marriage market. And then within each of these markets, there's 0 to k submarkets. Okay, so women are assigned to their submarket, and then unmarried men can choose which of these markets they want to go to. Once they've made their choice, they're randomly assigned to the women inside the market. Thanks.
When they get married, they exit the family?
Yes, I think that's true now. I mean, so we keep track of them because we keep track of their fertility behavior.
Then you have to replace them with a single clone?
No. No, they don't, people only get replaced when they become sterile. Okay? So again, this is the important thing to watch. Phi for submarket HK is the ratio of men to women.
And I forgot your utility function, so you don't want children as a man? You don't want to marry a woman with a lot of children?
The way it works is that the surplus, the utility flow from a household with stepchildren is lower than, it's a calibration detail, but yeah, that'll end up being lower than the household without stepchildren, conditional on the total number of children. Okay, I think I said this already. So, is there a diagram for this? No. Okay. So then, okay, what happens here? So in the sex market, what's going to happen is that once you're matched, you decide on a marriage plan, and then you find out, you have sex, and then you find out where the woman is pregnant, and then you find out what the abortion cost is. So what's a marriage plan? It says whether they will marry at the end of the period, and how this might depend on the state of the woman, like whether she's pregnant or not. I'll try to make that clearer when I get to the diagram. So given that you're together, and you have to make a contraception decision, the first step in that, though, is to think about what would happen if you got pregnant. Okay, so obviously there's going to be an option of abortion, and to decide whether you're going to have an abortion or not, you're going to wonder about you need to know the effect of having a birth on the couple's continuation value. So that's this delta V plus kappa. Delta V is the systematic effect, just like in the static model. And kappa is an IID preference shock. Now I'm going to take delta V as given for now, but it's going to be generated in the matching equilibrium. So now pregnant women can choose abortion. They have this IID cost, theta A. This is the distribution of theta. And so the probability that the abortion is optimal is the probability, of course, that the cost of abortion is less than the penalty for having a kid. So the expected cost of a pregnancy then is going to be this integral over here, which is basically the summation of the cases where the woman, where the couple decides to have the kid, times the utility gain from having the kid, and cases where the couple decides not to have the kid, times the abortion cost. Okay? So the consequences of pregnancy are summarized by this. Yes, Michelle?
I have a question about your marriage plan. So, I mean, what if they don't agree? So
They agree.
They agree because it's transferable utility, I suppose, but if they split up, so if they don't marry, then, I mean, you can't have a transferable utility across people who are not even together, right? And the continuation model is different because she's stuck with the kids now, he's not.
Right. So the assumption is that the utility is transferred at the time of the match.
The sex match?
Yes.
But if she's gonna not like it forever after, and he does, so he can transfer all that in a discounted flow already in that one period?
That's right. Yeah, these guys are good.
I mean, but I mean.
Yeah, that is the assumption.
I see.
Seriously.
So that's the.
Yeah. There's no constraint on how much utility you can transfer.
So they can just borrow against future income?
Well, it's not really income here. It's yeah. Let's not even go there. That's not even. Okay. So now let's assume we all understand what's going on with abortion. Then with contraception, then.
In all these other new technological changes on abortion, on particular abortion, the day after pill and things like that, with pregnancy tests, kind of interesting to so these things, must have reduced a lot the cost of abortion.
Okay.
But this is the 90s. That was
Yeah, I mean, it's something to think about in terms of pushing the model further, but we're not there yet. So a contraception method is basically a cost of contraception, theta I, and a probability of pregnancy, pi p. So we can sort out the model so that if a technology is more effective, it must be more costly to use. And so we can rank the different technologies by how much you have to want to avoid having a kid in order to use that technology. So then we can integrate out this cost of this timing cost of having a kid, this IAD shock, and we end up with the fertility frontier, okay, which is just the integral over all the different possible values of kappa. So this is what it looks like. If this is delta V on the horizontal axis, then you can, this is the birth rate as a function of delta V after we've integrated out those preference shocks. Okay, and over here what you have is how that birth rate is implemented. This green line is the abortion rate. I've assumed here a maximum probability of getting an abortion of 0.8. This is the rate of using contraception method 2, i.e. the pill. And this is the rate, this purple line that goes up and then down, is the rate of using contraception method 1. So if you really, really want to avoid a birth, of course, you're going to use the most effective method. But if you're fairly indifferent about a birth, you're more likely to use this less effective method. Okay, so this is how things work in the sex market then. To summarize, you meet in the sex market, you find out your match quality, you decide whether you're going to marry at the end. There's 3 different answers to that question. No, yes, only if pregnant. Then you find out how much you care about having a kid right now, and you choose your contraception method given this information. Okay, kappa and epsilon. You have sex, then you find out if you're pregnant or not. And if you're pregnant, then you find out the abortion cost, and then you decide whether to have an abortion. Okay, so the marriage plan could be summarized by these thresholds. This is probably fairly familiar. This is the match quality. If the match. Say that again? No, so these are nice people. There's no strategic behavior. They're fully committed. There's nothing hidden here. This, unlike the Akerlof-Yellen Katz people, the women are fairly nasty in that model. You don't want to mess with those ladies.
What does the son of another man do?
The sight of another man?
The son.
The scent?
The son.
Son, S-O-N.
Oh, the son. So the children always stay with the mothers. Is that what you're asking?
No, I said, do they make them more attractive, less attractive?
The men are more attracted to their own children. So they're happier to marry. Sorry. Go ahead.
Does it put if a woman has kids already,
Yes.
does
That
that make her less attractive?
It makes her less attractive in the marriage market
Why?
because the men don't like the kid. The men aren't really happy about marrying women with stepkids.
Was that directly on the
I'm sorry, I can't hear you.
Is that directly on the value function of these men?
Directly in the value. It's in the utility flow from the. Remember I showed you those household type utility flows? So if you raise Km, which is if you lower Km, that means that you're increasing the number of stepkids, and that reduces the utility flow from the household. Okay. So
I lost all of what you call the shotgun marriages, but what are they tomorrow?
Yeah, so that's a good time to ask the question. So a couple in the sex market will marry if pregnant under 2 conditions. Either they were going to marry anyway, so epsilon's greater than epsilon 0, or they decided they were going to marry if she got pregnant. So that means epsilon's greater than epsilon 1. So it's only these women here, these couples here, who don't marry in the case of a pregnancy.
And they do that because it lowers the trust of a man if he was only homosexual.
Well, it's cooperative, so I'm not sure how to interpret that. They do this because the total surplus from the match would be too low to justify getting married. Okay, so I basically told you about the birth control abortion type decisions, as if there was this number delta V that came out of nowhere. So in the paper I derived this delta V from solving the matching model given the birth probabilities and the expected cost of pregnancies. Okay, so I basically, to keep things simple, you can, if you know delta V, then you can solve all the fertility-related decisions and then plug them into the matching model and solve the matching model given these delta V's and these given these fertility decisions. So once we've done that, we solve the contraception model, solve the matching model, and then simulate a cohort between ages 18 and 44. So we just start people off at age 18, run them till age 44. Okay, so then I have a few minutes to talk to you about, right?
Yeah.
Okay. I have a few minutes to talk to you about how you can apply this now to data. And of course, there's some parameters in the model that can be set directly. So the pregnancy rate per contraception method, that comes out of data of analysis by Trissell at Princeton, the demographer. And actually, he also has a paper on the transition rate to sterility. Well, his paper is about the age-specific fertility rate. And so we can just set the transition rate to inactivity to match those rates from Trissell. And then, of course, there's going to be some pre-parameters in the model that have to be set somehow. And the way we do that, surprise, surprise, is to match a list of empirical targets based on the National Survey of Family Growth for 1973. Okay, so the transition rates, the participation rates. And what I'm doing here, the model isn't particularly good at matching long age profiles. So I'm going to set it, the model parameters to match the age profiles over the first 10 years, i.e. ages 10 to 28, which I think are the most important ones for the unmarried sexual activity. Okay, so where do these targets come from? Well, I didn't show you, but in the NSFG, we construct age profiles that are purged of education and other effects like age and cohabitation, and that break down the behavior by number of children. Okay?
I know that we spent the time, but I don't understand one thing. It seems that the elasticity depending on this distribution of other costs. Are you using a local elasticity? But there doesn't seem to be any. I understand that you want to explain the global effect over time, but it seems that you need a local elasticity to the technology to estimate this distribution of the cost.
Okay, so you're saying I need dispersion. I need some kind of dispersion parameter values. Is that what you're saying?
Well,
yeah.
You need to calibrate also those. It seems to be affected by the elasticity essentially, because you have a non-monotone. So if the elasticity is positive or negative, it will depend on the distribution of these parameters.
That's true. That's true.
So maybe a local elasticity, I thought you would have used as a.
So what is a local elasticity?
Well, for example, you see the effect of the short term of the introduction of the now is US. No, some change in the law that makes the access to the contraceptive easier, or increase in technology between 73 and 75, and then you simulate a model until the 90s, something like that.
I see. So you want to say let's break it down by more periods, and then use one period. Yeah, no,
possibility. I mean, unless you cannot calibrate without that elasticity.
Right. No. So let's just think about me. I'm basically punting on those elasticities. So I'm just I don't have anything that pins down those distribution parameters, the dispersion. So I'm just going to play it my way. Okay.
What do you mean you don't have anything that pins it down?
I have one. So I have basically a representative agent type of model with one, and I'm calibrating to one time period. So I basically can pin down the means of the distributions.
But isn't it this distribution that drives all of it? Because
Yeah, that's
basically
true.
moving guys from one market to another.
Yeah.
So it's how many guys are
Yeah.
in that range.
That's true. So the name of the game here isn't to prove that this model. I don't have a calibration that identifies those dispersion parameters. So before Flavio wakes up, I just want to move on.
You're not using the change over time or something to identify that distribution?
No, I'm not. 28 seconds.
All right, go ahead, Zach.
Okay. So I've told you more or less what happens in terms of the results. We start with keeping the maximum number of kids equal to 1. And then we calibrate to the 1970 stuff. And then we're going to run an experiment where we change the cost of probability of pill access to match pill usage rates by marital status. And that's going to be sort of represent the 90s. Okay? I'm not sure if that was clear, but let me show you a table that maybe makes that clear. So here we have a list of targets from the data. Here's a list of analogs from the model. And then we change some parameters over here. So we change the access to the pill, the cost of the pill parameter, and to match the pill usage rates, and then see what the model kicks out relative to the 1990s data. Okay, so it's data, benchmark model, data for the 90s, and then experiment. Okay, and so what happens here, what the message of this table is simply that when we calibrate this model to the 1970s data and then change the cost of the pill, we end up with very high unmarried birth rate and a very low marriage rate. Okay, so that's a small victory. The problem is that we didn't talk about shotgun weddings yet. When we put those in, so this is the result I just showed you. When we put in the shotgun weddings, though, the marriage rate declines as before, so that's kind of nice. The unmarried birth rate rises, not as much as before, but the shotgun wedding per pregnancy ratio stays constant. That's bad, because that was the fact that motivated Akraloff, Yellen, and Katz.
Do you want to compare the cost of shotgun marriage to the cost of abortion?
Yeah, that's what women are doing. That's what couples are doing in the model.
So what are the, actually, I don't know the law, but what is the cost of a shotgun marriage? Is it easy to impose if you don't want to marry?
Well, I mean, at the margin, it's going to be equal to the cost of an abortion. And it's
Because
the best.
of being much of the wrong guy, gets stuck with the wrong person.
Oh, I see. Okay, thanks. That's a better answer. Yeah. Okay, so so this just shows that when we add we look at the shotgun wedding rate, we can do two things. We can either just keep the distribution of quality constant, and then the shotgun wedding rate goes way up in the 90s when we recalibrate the model, or we can shift down the distribution. This is in the spirit of Akraloff, Yellen, and Katz. Say, well, now the women who want the shotgun wedding are bad women. But that then drives down the sex rate and drives the unmarried birth rate way down. So now we have a bit of a problem. That's what I just explained. So what happens now is abortions aren't going to help. They drive the unmarried birth rate down even lower. And what we have to do in the end is increase the maximum number of children. And as I said before, now we get the sexual revolution margins. I think I have a slide that summarizes this here. Now we get those margins that we were after. So now the shotgun wedding rate declines to basically what we see in the data. The marriage rate declines to about 0.2 relative to 0.12 in the data. And the unmarried birth rate goes up to 0.06 relative to 0.07 in the data. Okay, so by allowing for activity of unmarried mothers, which I think have basically been ignored in this literature, we get these more realistic responses. And the critical thing to add in, that we had to add in here, was the abortion market. Okay, so conclude. Previous analysis relied on social norms and strategic interactions to explain rising share of unmarried births. This paper says decline of shotgun marriage. Actually, you can think of it as just the intentions of nice unmarried couples changing as the relative attractiveness of single life increased. So we get higher pregnancy rates of unmarried women because birth control lowers the cost of sex, bringing them into more women into the sex market. Lower marriage rates because higher sex rates generates a higher value of single life, and a decline of shotgun weddings because the presence of abortion reduces the risk of coming up against the, I guess, the maximum number of children. So the quantitative analysis that we did was possible because we had a model with long horizons, empirically relevant margins, and basically an unlimited potential number of kids. So there's obviously stuff I've left out. You guys probably noticed half the stuff already, or if not more. So we could, by our logic, we should be extending k to greater than 2. And in the 1970s, half of unmarried births were actually accounted for by single mothers, so this would be a sensible thing to do with our model. There's an identification issue that was raised by Nicola, I think. We don't really know how to pin down the variance of the distribution. So it would be nice to have ideas on that. And then in the end, we can expand the model by allowing for divorce and allowing for investment in children to think about the welfare of children and how that changes as the marital regime changes. Now, you've been very polite not to harass me about cohabitation, and I assume that shows superior insight relative to previous audiences. I think of cohabitation as a kind of dating in this model, particularly I think up until the late 1990s. That's a fairly accurate description. But you could also think of cohabitation as another consequence of the relative attractiveness of single life. Right? So you can think of this, anyway, I'm done. I'm sorry, Flavio, I went 30 seconds over time.